Hi everyone, welcome to the fifth lesson for topic 4.2 Loans, Investment and Annuities. For today's lesson, we are looking at something new which is called as reducing balance loans. So it's an idea that very similar to what we learned in our previous lesson, which we talk about investment with regular deposit. So for reducing balance loans, in another words, is actually compound interest loans with regular repayment. So in an idea for investment, right, we talk about the situation where we put in more money so that we can generate more interest from the account. So from that, we earn more money. So in this case, we are talking about loan. So as we try to make repayment, right, then which means that the amount of money that we are owing is actually getting lesser and lesser. So that's why the interest generated on the amount that we are still owning is kind of like decreasing as well. So from that is something that is beneficial for the one that is trying to borrowing the money as well. All right. So same thing, we are going to look at how are we going to use recurrence relation to model what happened in a reducing balance loan account. Then after that, we also try to see how are we going to use our calculator to use our finance solver in our TI Inspire to help us to solve the problems. All right, so now let's move on to the content part. All right, so we'll start from the definition of reducing balance loans. So like what I have mentioned previously, so we have people that make regular contribution to the investment so that they can generate more interest. So the same thing for a loan, people also make regular contributions so to reduce the balance of loan. So this kind of special loan is called as the reducing balance loans. So I'm trying to put in this blank here so you can try to write down for one time that you can remember this name of the loan. All right, so a reducing balance loan is a loan that the interest is calculated on the amount of money that's still owing after each repayment is made. So you can try to imagine as if you borrow some amount of money, right? Then the bank will generate interest. So if you are able to repay, the repayment that you are having is higher than the interest generated, then eventually what happened over the life of the loan is that the amount of money that you owe, right, is reducing, right? Because if not, if the amount of owing is increasing after each repayment, then which means that for forever you wouldn't be able to repay the loan, right? So over the life of the loan, the amount of owing reduces after each payment. So that's why the interest that charge is also reducing as well. All right, so I hope that I can get this idea from this simple illustration that we are going to do here. So same thing, I'm going to show what happened to this loan account from time to time by using this timeline. Okay, so what happened here is that Jim wants to buy a motor scooter. So he borrows 5,000 from the bank. So this is like at the end of the 0 year, like it's like where this loan start. All right. So in the account at the end of the 0 year, that which means that Jim borrows $5,000. All right. So what happened is that after that, for each year, he is charged for 5% interest per annum. So which means this amount of money will get charged of 5% of interest. All right, then at the end of every 1 year, he manages to repay $500. So which means that the amount of money that he is owing after adding 5%, then he is able to repay 500 at the end. All right, so from that, we'll be able to get what is our value that Jim's still owing after at the end of the first year. Okay, so let's try to calculate this. So by using the same idea as well, so you can see $5,000 generate 5% of interest. So which means that the total amount that Jim's still owing will become 5,000 multiplied by additional 5%. So which give you 1.05. So you straight away get the total amount of money, right? Which means the initial 5,000 and also 5% from interest. All right. So 5,000 multiply 1.05, then from here, then I'll be able to get the total amount of money that he's still owing here will become 5,250. So at the end of 1 year, he also repay $500, right? So at the end, you the money that you owe minus the repayment, then you will get the total money that you still owe. So which means that we got 4750. So you can get this from 5,250 minus $500. So what you can realize here is that the total amount of money that's still owing after repayment is kind of reducing as well. All right. So after that, what happens? So this is at the end of the first year, right? So we have 4750. All right. So after 1 year, what happened is that this amount of money is going to generate another interest. Am I right? So the bank is going to charge the new interest on the amount of money that he is still owing. Then after that, he repay another $500 as well. So at the end of the second year, he will be able to get 4750. Same thing, multiplied by 1.05. So you get the total amount of money that still owing after the interest is generated. So from here, then we can get 4987.50. So after minus $500 repayment, then the total amount of money that he still owe will be 4487.50. So I hope that by now you'll be able to see the pattern. So the same thing is going to happen as well from here. So you are going to get charged for another 5% for interest. Then after that, repay another $500. Get charged for another 5%. Then after that, you repay another $500. All right, so by using this idea, let's try to work it out for the end for year 3 and also year 4. So you can get 4487.5 multiplied by 1.05. So after the interest is charged, then we get 4,711.88. So repay another $500. So now he owes a total for 4,211.88. Alright, so similarly, when we move on, then we have 4211.88 multiply 1.05. So we can get 4422.47. So from here, we pay another 500, then we can get 3922.47. Alright, so something that you should realize here is that you see after each repayment, right, the total amount of money that he's still owing is kind of reducing. So that's why the 5% of the interest charge will reducing as well. So it's not the 5%, the 5% remain, but because of this amount of money that you are getting charged for, the 5% is reducing. So that's why the interest is reducing as well. So that's why by using this idea, you can see from year to year, then until a certain year, he will be able to pay off his loan. All right, but something that we might need to bear in mind is that you must make sure that the regular repayment that we are having, right, should be an amount of money that is more than the interest. So for example, you can see that the 5% for 5,000 is actually 250. So that's why the repayment is actually more than the interest for 250. So that's why you have a kind of like decrement in your total amount still owing by 250. If let's say this regular repayment, right, is less than the interest, this is like what I mentioned previously, then forever you won't be able to pay off your loan because your repayment is not even enough to actually pay off your interest. Then after that, the total amount of money that you are still owing after each repayment will getting increased and increased. Okay, because the interest generated here. All right, so by looking at this situation, you can see that it forms a recurring patterns as well, right? So you can see that this pattern recurs at 5% minus $500, at 5% then minus $500. So that's why we can try to express this in a recurrence relation as well. So you can see that how do we get our next term? We normally use our previous term to multiply by 1.05, right? So multiply by the n term. Then after that, we minus off the $500 that we repay. After that, don't forget T0 will be equal to 5,000. So this is the recurrence relation for this question. Alright, so now same thing, we are going to go through how do you use your calculator to press this. Then after that, we look at the examples together. Alright, so this is something that we learned previously when we learned about investment with regular deposit. So that's why I'm just going to do a very quick revision. After that, we can look at some, the question with more complexity. Alright, so let's try to go through this. So by having our recurrence relation here, so two ways that you can try to do that. So either you can try to put your 5,000 as the first cell, then after that you just try to generate your sequences by using the formula here by giving the order to the calculator. So which means how are you going to get the second term? You use 1.05 to multiply A1. So which means is our first cell here, right? So which means column A and then row 1 to get this cell. Then after that, we minus off 5,500, then you'll be able to get the second value. So after you find out T1 in your table and then the number 2 data in your calculator. So I hope that I doesn't really need to explain this anymore, right? So you can straight away look at your table, then you do your own comparison. So this stands for T0, then T1, T2. So that's why the number that you're having here is one more than the normal table that you're having. Okay, so now then the same thing lah. So make sure that you highlighted this cell, down to that menu, data field, down to that just go down until the steps that you want, then press enter. So you'll be able to see that you are able to get all this value when you try to compare to our calculator here. So that's why the answer here are all correct. Okay, then when you try to move on, right, you'll realize you will actually encounter at some phases, right, you will be able to get like from a positive value to negative value, and that's basically the end of your repayment. Then later we are going to learn how do we find out the final repayment. Alright, so that's the first method. Then after that, the second one, of course, is to generate the sequence in our calculator. So menu, data, generate sequence. So 1.05 multiply UN minus 1 and then minus of 500. Okay, so initial term 5,000, then you just tap everything, then okay, then you will see you get exactly the same sequence as well. So that's the second method. And last but not least, we know that we can use our finance solver in our calculator as well. If let's say the question didn't require us to do recurrence relation. So menu, all right, finance, then finance solver. So something that interesting about this is you might want to remember that in this case, right? Okay, let's try to find out for the fourth year maybe. Okay, so this is compounded annually, right? So that's why 4 times at the end of the 4 year, you have already paid 4 times. So 1 time, 2 time, 3 time, 4 time, right? So that's why the end here will be 4. So interest rate here is 5% per annum. So PV here, remember, you are borrowing an amount of money. So that's why when you are borrowing the loan, right, the amount of money is with you, is in your hand. The money is given from the bank to you. So that's why the present money, the PV here, is going to be a positive value because the money is given to you. So that's why in this case, we got our PV here as 5,000. So payment, when we talk about repayment, you are giving this money to the bank, right? So that's why negative 500. So FD is what we want to find, how much of the value that I still owe the bank after 4 years. So PPY, CPY still 1 because in this case, we are looking at the situation where repayment is done for every year. Then the interest is also compounded for each year as well. Then just tap everything until you go back to FV, then press enter. So you'll be able to realize that you get the same answer as what we have T4 here. So you realize that why is this negative? Yeah, because you still owe the bank money, right? So that's why negative 3922. Okay, so that's the idea. Alright, so now we will move on to the example. So I guess from there you'll be able to look at the more complex, the more complicated question. So hopefully from there you'll be able to tackle different kind of question. Alright, so let's look at question 1. Alright, let's look at the example. So you'll realize that the example here is much harder when you try to compare to the previous one because the situation that involving reducing balance loans is kind of more complicated as well. So try to understand everything that you are doing. So that's why you are not memorizing everything to solve the situation. Alright, question 1. Lily borrows 30,000 at a rate of 8.5% per annum adjusted monthly. So that's why this interest rate is compounded monthly. After that, the repayment is $650 per month. So that's why CPY and PPY are both 650. So part A, Find how much is still owing on this loan after 2 years. So same thing, I'll try to show you two methods. The first one by using the recurrence relation, then the second one by using the finance solver. So let's start with the first one first. So this is part A. Alright, so for 1. Okay, so if you think that you need to, then you can try to draw the timeline as well. So this is like the money, 30,000. Then after that, what is going to happen? So you are going to add 8.5% as interest. Then after that, minus of 650, right? So I hope that you can imagine all this. Then after that, we try to straight away write down our recursive rule. So first one, if by using recursive rule, then we know that how do we get the next term? We will use the previous term to multiply by 1 plus, so what's the percentage here? Is 8.5, right? So we straight away change it to decimal. So we have 0.085. So we want a monthly interest rate, right? So that's why divide by 12. Okay, then after that, multiply by Tn, the nth term, the previous term, and after that, minus off the repayment for 650. Alright, so I hope that you understand how this thing works. Then after that, T0 here will be equal to 30,000. So this is our recursive rule. Then after that, we are finding how much is still owing on this loan after 2 years. So which means that after the 24th month, after the last repayment is made. So which means that we are finding T24. So just generate this sequence in our calculator here and see what can we get. Alright, so let's go back. Okay, so menu, data, generate sequence, right? So in this case, you can straight away press this thing. So which means that 1 plus, and then after that, 0.085. Okay, then over, or you can just put the divide. Alright, then 12 multiplied by, so remember another bracket, multiplied by u and minus 1, and then minus of 650. Initial term 30,000. Then after that, just tap all the way until you get the last answer. So you should be able to get this. Then after that, we try to find out our T24. So T0 in our recursive rule is going to be the T1 in our calculator. So that's why this is like our 0, 1, 2, 3, right? So 24, it will be the 25th value. So that's why just go down until you reach here. Alright, so I hope that you can get this answer here. So we can see that we are going to round this off as well to to dollar, right? So that's why maybe for the first one, you can try to write the whole value first. Okay, and you must know that at the end, because we are talking about money, so that's why we just round it off to 18598.56. Alright, so this is the amount of money that she is still owing after 2 years. So same thing, let's try to do the second method here if we are using our finance solver. So in this case, we have our n here. So n is going to be 12 times per year, right? So that's why after 2 years, then it will be 2 times 12. So which means it will be 24 payments made. Then after that, the next thing, we are having our our interest rate first. So 8.5. All right, just give your answer per annum. Then after that, our payment here will be equal to, sorry, I should start with my PV first. So the present value, how much I borrow. So the present value, the money is now with me. So that's why it's going to be positive because I borrow the money is given to me. So 30,000. So PMT here is equal to negative 650 because I'm giving this money to the bank. And then PPY and CPY in this case are both 12 because it's compounded and the payment is made monthly as well. So in this case, we are finding our FV. So let's try to input all the value in our calculator and see what can we get. Alright, so go back to our finance solver. Alright, so N is 24, 8.5, PV 30,000, so PMT negative 650, FV is what we want to find. Then after that 12 and 12. Okay, so just tap all the way until you're back to future value, then just press enter. So you should be able to get the exact same value. So the answer here will be negative because that's the money that you still owe the bank. So that's why FV will give us an answer for negative 18598.55869 also. So at the end, he still owe, so 18598.56. Okay, it's still owing after 2 years. Alright, so I hope that this question is very straightforward. Okay, so now let's move on to B. So how much interest is charged during this period? Okay, so this is a little bit tricky. So which means that we want to find out the money that you pay throughout this period, right? Actually, how much of it is actually for the interest and how much of it is actually for the repayment. So that's why if let's say you want to find out the 8.5% for each of the period, it will be kind of difficult because you can imagine that the 8.5% is charged on different value after the amount of money owing is reducing as well. So that's why you can't actually forms like a sequence from that. It will be kind of complicated. But what you can imagine is that this money, you can try to find out what is the total repayment that you have made so far. Am I right? So let's try to do that one first, then maybe from time when we move on, then I'll try to explain it from there. Okay, so what is the interest is charged during this period? So which means the periods of 2 years. So what is the total amount of money that I have repaid throughout the 2 years first? So for the total repayment in 2 years, alright, is actually equal to our $650 per month, right? So multiply by 24. Okay, I hope that makes sense. So every year, every month you pay for 650. So that's why for 2 years, you already paid 24 times of it. Okay, so from here, we'll be able to get that the total repayment in 2 years is actually 15,600. All right. So now what we can realize is that is the account owing reduced for 15,600? The answer is no, because you can realize that previously, right, this is the amount of money that you are owing. After 24 months, this is the amount of money that you are owing. So that's why you can see that when you use this money to minus off this, right, you will be able to get a number that is smaller than 15,600. Reason being is because of some of the payments, some of the repayment that you are doing is actually for the repayment for the interest. So you can imagine the idea, right? So, okay, let's go back to this table maybe. So you can see that in this case, right, you are repaying for $500. But is this $500 going to be deduct from your 5,000? The answer is no, right? Because you realize that out of the $500, 250 is actually to pay for the interest. Then after that, 250 only the one that you are paying for your loan. So the same thing happened here. So you can see that from 4750 to 4987. So you have like 237.50. So you also have this 200 something of value that you are paying from this 500,000 to pay for your interest. Then after that, the rest of the money pay for your loan. So it's the same idea in this case here. So we can try to find out what is the reduction of the account here. So which means that we can find out the reduction in the amount of money that we are still owing. So reduction for amount owing. So we can see that for the starting of this loan, I owe 30,000. So after 24 months, after 2 years, now I owe 18,598.56. So from here, I will be able to get the reduction for total amount of money owing. Alright, so after I minus, then I'll be able to get 11,401.44. So which means this is the real deduction that I see from the amount of money that owing. But you realize that I actually paid this much of money during 2 years, right? Then where are the others money go to? So the money is paid for the interest. So from here, then I can just use my 15,600 to minus off the reduction. Then the rest of the money actually goes to interest. So from here, then I'll be able to find the interest generated throughout this period. So from here, I'll be able to get 4198.56. Alright, so I hope that you can get the idea of this thing. So again, try not to memorize it, but to understand how this thing works. Then from there, you'll be able to know how to solve it. So which means you pay this much of amount, but then the amount of owing the reduce only this amount. So that's why you know that some part of this money is actually paid for the interest. So when you try to minus off the real reduction, then you'll be able to get this value, and that's basically your interest here. Okay, so now move on to part C. So you'll realize this question is quite long because I'll try to look at one situation, then you can try to look at the different thing that a question can ask. So to try to explore the different situation that you might be having in financial mathematics. Okay, see how many repayments are required in order for her to fully repay the loan. Okay, so in this case, you are finding what is the time where your amount of money that you are owing eventually becomes zero. So that's the idea. So which means in this case, we can use two methods to do it as well. So same thing, the first one, we can try to use the recurrence relation. So why is that so? Because you can always see from the recursive rule when your rule or when your recurrence relation, when your pattern go to a negative number. So let's go back to this sequence. Okay, so you can see as you go on, right, you'll realize that at some time now, the total amount of money that you are owing become a negative value. So that's the time where where you actually finish your loan. So which means at the 56th month, you owe for $57.54. So at the 57th month, you actually finish owing. So that's why you are given like more money. So that's why the amount of owing become negative because you are giving like more and more money, and in the case where the money is already finished paid. So that's the idea. So that's why by looking at this, then we can try to write down our T56. Alright, so at the 56th month, I'm still owing for 57.54. Okay, then I move on when I am at T57. Then I'm still owing a money of, oops, sorry for that, negative 592.05. So that's why by looking at this, now your amount of owing become negative already, and that's the time that you finish paying lah. So that's why in this case, we can see that 57 repayment are required. Alright, so this is one way to do that. Second way, of course, we can try to use our finance solver. So same thing when we are using our finance solver. So N here is what we want to find, right? Because we want to find out how many repayments we need to do so to finish off the loan. So the I here is still 8.5. PV here is still 30,000. So our PMT here is still negative 650. Okay, then after that, our FV, we want the loan to finish, right? So that's why the future value for our loan should be 0. So which means you clear off all the loan. Then after that, PPY and CPY stays the same, which is 12. Alright, so as we move on, then we can try to key in all this value into our calculator and see what we can get. Alright, so menu, finance solver. So same thing, let's try to key in all the value. So I here is 8.5. Moving forward, PV here, 30,000. I think the rest is the same, just that FV, we are changing it to 0. So just tap, then after that, go to your end, then after that, you press enter. So you'll be able to get this value. So you can see that even the value here is given like 56.088866. But the idea is, you know, that by looking at this question, right, you see that the repayment is made 650 per month. So that's why you, even though you only left with like 57.54, but you cannot pay it together with the previous month, because for every month you only made one payment. So it's the same thing. Although you need 56.088 kind of repayment, but at the end, which means that you need to pay this remaining of 0.0888866 in the next month. Am I right? So that's why in this case, remember that you will always need to round up but not round down. So in this case, it's the same thing of 57 repayments are required. Alright, so that's the idea. I hope that you can get it. Alright, so now we move on to the next part, which we talk about what is the total amount that we paid on the loan. So for this question, it's actually a little bit complicated. So I hope that you can try to follow and try to understand why are we doing so. Alright, so the tricky part is actually for the part where you want to find your final amount of money that you repay. Okay, so we can try to understand it from this idea. So you can see that although we need 57 repayment to actually finish our loan, right? But you realize that at the end of the 56 year, you only owe this amount of money. So that's why you are not going to repay another $650 at the end for the 56 year. Am I right? So that's why we need to find what is our final payment. Then only we can add up the previous one so that we try to find out what's the total repayment that we have made so far. So same thing, I'm going to show you two ways to do it. So the first one, we'll start with our recursive rule first. So let us try to just copy down the information that we are having in part C. But in this case, we might need to give more decimal places because at the end, we are going to use that to do calculation. So by using our recurrence relation, we can get that the 56 term is 57.5416, and then at T57 is negative 592.0508. Alright, so in this case, when we move on, so now we are going to understand it from a timeline perspective. Alright, so when we try to look at this idea, right, so you can see that this is what happened. At the end for the 56 year, I still owe this amount of money. So this amount of money is going to be charged on another 8.5% per annum. Am I right? So 8.5%, let me try to write down per annum lah. So later we are going to change this. Then after that, minus of 650 and you get the next term, right? This is normally how your pattern is recurring. But now you realize that even this value after you adding the 8.5% per annum, right, you are not going to achieve a number that is more than this. So that's why you are paying extra money to the loan. So you can see that the sequence here become negative. So which means that you are paying an extra money of 592.0508 to the account. So that's the idea why your recursive rule become a negative number. So until here, I hope that you can see the two methods that you can try to solve this question already. So the first one, definitely from the timeline, you can see that the value that I am going to repay here is no longer to be 650. It's going to be the value that after adding this 8.5% per annum to the total amount of money that I'm owning. So which means that for the first case, I will be doing the final amount here, final payment is going to be equal to 57.5416. This is why we are writing more decimal places, because we are using this to do some calculation. And then multiply with the same thing. So 8.5 is per annum. So that's why 1 plus 0.085 divided by 12. You can see this is just like the first half of your recurrence relation. Because we are not taking this part, right? We are looking at how much interest is charged, then after that, plus with the original amount of money that I'm owning. Okay, so now when we move on, so for this part, then we will be able to get 57.9491 9. Alright, so try to round it into two decimal places, then we can get 57.95. Alright, so that's the first way to find it. Second way like what I have explained just now, right? We say that this amount of money is the extra money that you pay. So which means that after you are paying 650, you have this much of balance. You have this much of extra. So that's why the other alternative is we can try to find the final repayment by using the 650, then minus off the extra money. So after you minus off the extra money, you will be able to get the exact money that you actually return to this loan now, right? So that's why 650 minus of 592.0508, you should be able to get the exactly same value here. And then after we round it, then you'll be able to get 57.95. So that's why they are just the same. So the idea is that whether you want to understand it from a perspective of a timeline, that you want to use the amount that you still owning in the before the last payment, then you just multiply by the interest. Then the other thing is you find out what's the extra money that you pay. Then after that, you use the repayment to minus it. Then you'll be able to find out what's the exact value that you need for the loan to complete. All right, so that's the first idea, which means we try to use recursive rule to do that. So I'm going to show you the second way first, then to show you that the final payment is just the same. Then after that, we only calculate the total repayment together. Okay, second way by using calculator. Then how can we do that? Okay, so in this case, right, let's go back to our finance calculator. Okay, so you can see that previously when we try to calculate this, you realize that we need 56.088866555355 to actually finish off this. And at the end, we know that we are going to do it at the end for the 57 year, right? So that's why what we try to do is we should always change our finance calculator here to be n equals to 56. And the rest are just the same. Then you just find out what is the final value that you still left after the 56 here. Then you'll be able to get this amount. So that's why let's try one time. So you can see 56. Okay, so you cannot do 57 because when you do 57, you can realize that your FV will become positive already. It's like you're giving more extra money also. Then after that, you just tap everything until you reach FV. So you can see that you're still owing this amount of money. So it's the same thing like what we discussed previously. So in this case, by looking at the end for the 56 year, I'm still owning an amount of money which is negative 57.5416. All right, so that's why I know that the final payment will be equal to is the same thing like how are we doing this before. So 57.57491 16 multiply 1 plus the 0.8% multiplied by 12 because it's per annum. All right, then at the end, we'll be able to get the exact same value as well. So no matter which one that you are using, the final payment is still 57.95. All right, so I'm going to use the other color. So this is like continuing these two because the question one is to find out what is the total amount repaid, right? So that's why the total amount repaid okay, it will be just equal to, so the previous money, so it will be for 56 months, we pay the regular repayment. Then after that, for the last one, we pay 57.95. So by adding them together, then I'll be able to get 56, then plus 57.95. All right, so I'll be able to get a total value for 36457.95. So you'll realize that I actually borrow a money for 30,000, but at the end, I actually repay this amount of money. So you realize that this amount of money should be more than that. If let's say you get lesser than that, then how bank is earning money, right? So that's why after interest is generated, everything that obviously the total amount that you repay is going to be more than the real money that you actually borrow. And this one is considered quite okay. Later when we are looking at housing loan, then you'll realize that sometimes the interest even much more than the money that you actually pay for the house. So that's the sad reality about owning a house lah. All right, so that's the part for D. I hope that you can understand. And now we move forward for part E, the amount of interest paid on the loan. So I think this one is quite obvious lah. So you can just use the total amount of money that you pay. Then after that, you just go and minus the total amount of money that you borrow. So 3645.795 minus of I only borrow this amount of money. Okay, sorry, just try to add it in here. So the interest for the whole thing lah. Alright, so this is for the whole period until the 57 month. So I'll be able to get 6457.95. So this is the total amount of money that I pay as the interest for this loan. So don't forget about the unit as well, the dollar here. So now let's move on to question 2. Alright, number 2, Andrew took out a reducing balance loan for 60,000 with interest calculated monthly at a rate for 10.25% per annum. So remember, this must change to monthly rate. Then after that, he also makes monthly repayment for $918.41. So question 8, the question asks, how long will it take Andrew to repay the loan? So the same thing, two ways that you can try to do it. First one, recursive rules. Second one, by using our finance solver. Alright, so same thing, we are trying to go through both here because the question here is a little bit different with the previous one. So it's okay that we just try to expose you to different way of solving question lah. Alright, so let's try to practice how to write our recursive rule here. So same thing, how do we get our next term? Is by using our previous term, then we try to find out the interest generated here. So 1 plus, so 10.25, let's change it to decimal. 0.1025 divide by, this is per annum, right? So it's calculated monthly, so divide by 12. Alright, then after that, multiply the previous term. So the interest is charged. Then after that, you repay for $918.41. Alright, so that is our recursive rule here. And don't forget, T0 is equal to 60,000. Alright, so how long will it take Andrew to repay the loan? So we need to generate this sequence in our calculator. Then we try to see from the positive value to the negative value. Then from there, we'll be able to find out how long he needs to repay the loan. So that's why let's try to solve this. Okay, so let's try to do the recursive rule first. Alright, so menu, data, generate sequence. So you do not need to simplify this straight away, put this in a calculator. So remember bracket lah, 1 plus bracket 0.1025 divide 12, close the bracket, another bracket because you want to close the whole thing, right? It's like the whole thing here. Then after that, multiply by UN minus 1 and then minus 918.41, and the initial term here is 60,000. Alright, so just tap all the way, then just press OK, then you'll be able to see the sequence here. So as we move along the column, alright, you realize that the negative happens here. So you can see that at T95, you are still having amount of money that you are still owing. Then after that, 96 onwards, then you have negative value. But of course, this one, the repayment wouldn't be that different because you're only left with, the extra money that you are paying is only like 0.56. So that's why at the end, you are still paying something that is very close to 918.41. Alright, so anyway, just write down our answer here. So T95 is 910, T95, 910.09069. Alright, then after that, T96, then we'll be able to get negative 0.568. Again, I hope that I do not really need to explain about the numbering anymore, right? You should be able to know. So 1 in our calculator is your T0. So that's why when we are looking at T96, we should be writing down T95, then T96. So this is the first term that it becomes negative. So that's why we need 96 ones. Alright, or in this case, you can try to give as well, 96 divided by 12, you can get 8 years as well. Alright, so that's how you get it. Then after that, part 2, same thing. We can try to use our finance solver to do that. So we are finding what is our end that required to finish the payment, right? Then after that, when we move on, then we can find out the I is equal to 10.25%. PV, how much we borrow. So the money is with us, so that's why it's positive 60,000. PMT, I'm giving back to the bank for negative 918.41. FV is what? 0. All right, because we want to pay off the loan, right? Then after that, CPY, PPY are both 12. Okay, so let's key in all this in our calculator. Alright, so N is what we want to find, and I is 10.25, PV 60,000, PMT negative 918.41, FV 0, then 1212 is the same. Alright, then okay, then you will be able to get 95.99938. So this number is close to, remember to round up, right? So 95.999 and so on. So that's why when we try to round it off, then we'll be able to get 96 months, which is the same thing as well, which is 8 years. So how do you know that it's month? Because your CPY and PPY is 12, so that's why 12 payments, so 96 times of payment. So which means that it's going to be 96 months because for each month you pay one time, right? Okay, so now this is the different question than we have in our first question just now. So after 3 years, he increases his monthly repayment to 1,200. So by how many months is the length of the loan reduced? So you can see what happened here is that you are having two stages here. So for the first 3 year, right, try to look at this as a timeline as well. So for the first 3 year, what happened is that the repayment that happened is 918.41. So after 3 years, he kind of like increasing the repayment until 1200. So that's why what do we need to find first before we can straight away move into the part where you want to find out the length reduced is that we want to find out for this part, right? You are having you are still owing 60,000. So after the first 3 year of paying, after the first 3 years of interest generating, then you pay $918.41 for each month, right? What is the value that you are still owing here, right? So I have my new PV here, then after that I put in my second situation. So from there I'll be able to see how long the period that I need so that I clear off this loan until 0. So obviously by comparing to our part A here, it's going to be something that is shorter because in part A, every month you only pay 918.41. But in this case, in every month after the first 3 years, you are going to pay 1,200. So that's why your loan should be finished earlier when you try to compare to the part A part. Alright, so now for this question, we are just going to use our finance solver to do it lah. It will be kind of like easier as well because you can just change your number in the finance calculator. Okay, so how should we do this? So same thing, the end. So for the first 3 years, so every year you pay 12 times. So that's why 36. Then after that, I here is still the same, which is 10.25%. Alright, PV, you borrow 60,000. Move on, the payment here is still negative 918.41. Alright, so the FV here is what we want to find, right? What do you want to, how much do you still owe after the first 3 years? Okay, then CPY and PPY are still 12. Okay, so let's try to do this in our finance solver. Of course, you want to generate your sequence also can, it's the same thing. And I think maybe when you try to do your sequence, it's easier that you can straight away get the answer. Okay, it's okay. We can do this first, then later I go back to the page for the recurrence relation. So which means that you are still using the same thing, but you can straight away read the 37 data. I hope that you get what I mean. Okay, so the end here 36. So the rest of the number is just the same and we are finding the FV. Okay, so you can see that after 3 years, you still owe the FV here is equal to negative 42975.7314. Okay, so which means that still owe 42,972.73 after 3 years. Okay, so if you are using recursive rule to solve it, right, because you already generate the whole sequence in part A, so I believe that you can straight away get the answer as well. So by looking at your recursive rule, so you can see that just go back to find the 37 value log, which is the 36 at the end of the 36 year. So you should realize that this value is just the same. You see the value here and the value here. Alright, so it's just the same. So that's why which way to do also can. Alright, then now we go back to the finance calculator. Okay, so after we found this, then which means that this is the value here, right? So that's why I will have my new PV here. So the present value that I owe is no longer 60,000 after 3 years. It's going to be 62,000 and blah, blah, blah. Alright, so that's why in my new situation, so after 3 years, I'll be having the other situation because my PMT is going to change as well, right? So after 3 years, so N is what I want to find because I want to find how many payments do I need to clear off the loan. Then after that, I is the same, which is 10.25%. So PV now I only owe 42975.73, right? Okay, then moving onwards, I have my TMT. So now for each year, I'm paying 1,200. Okay, because he increases the monthly payment to 1,200 after 3 years. Okay, so the same thing, FV here will become 0 because we want to find out when the loan finish. So CPY, PPY is still the same because there's no change stated in the question, right? Okay, so when we are here, then the same thing, we just try to put them in the calculator and see what's the n that we can get. So n, we are not going to change anything, leave it. Then I is the same lah. So PV is the one that you want to change it. So instead of putting this money, then what you can try to do is you move on to this place. Then what you can try to do, just Control C. So you are copy pasting everything. So copy this, then after that you just tap everything until you go on to PV. Then after that you press Control V. Alright, so can you see my V? Control V. So you can see the whole value is pasted here. So it's more accurate lah. So the PMT here is negative 1,200. So remember this one you should change it to positive because that's the money that the bank given to you. You are not paying back yet. Alright, so the FV here is 0. So we can go back to our end here and see how long do we need to actually pay off all the loan. So you will realize that you get 42.93. So N equals to 42.93, which is roughly 43 months. So when you try to compare to our previous one, then you'll realize that in this, right, okay, we might want to find out the total first lah. Okay, so the total will be your starting, you still have 3 years, right? So don't forget that. So 3 years, you pay for 12 times, then after that plus 43. So which means 36 plus 43, you need 49 months. So when you try to compare to your part A and part B, because the question wants us to find out by how many months is the length of the loan reduced after you increase the monthly repayment. So that's why in this case, we'll be able to use our 96 to minus off the current one. So which means the length is reduced by okay, so previously we need 96, right? So 96 minus 79, then we can get 17 months. So you actually finish earlier compared to the previous one. Alright, so that's the part. So yeah, I hope that is quite clear here. Alright, so now let's move on to the next question. Alright, so now we have our last two examples here. So you can see that I try to differentiate this part with the previous part because the two examples that we are looking now are loans with deposit. So which means that in the previous cases, right, you realize that no matter in the illustration or in the two previous example, the situation that we are having is you borrow an amount of money, then you did not actually have any deposit, then you only repay some amount of money by monthly or yearly. But loans with initial deposit is something that is much more closer to our real life situation, no matter you are talking about buying a car or buying a house especially. So normally what happen is, for example, like example 3 here. So John wants to purchase a house costing 480,000. So he will kind of pay a deposit for 30,000. Then after that, the remaining only borrow from a bank. So the only difference between these two examples then and the previous one is that you are paying a deposit before you are giving the repayment. But the idea is just the same. So you can remember it as if like this. So which means that let's try to go through a question first maybe. So this is the total amount of money of your house. Alright, so yeah, the total amount of money for your house. So you pay for a deposit for 30,000, then borrow the remaining. Okay, so which means that for the loan itself, actually how much I borrow? I only borrow 480,000 minus of the deposit because this is the money that I already have, right? So I pay it. So that's why I only need to borrow $450 from the bank only. So that's the idea. So the bank charges a fixed 8% per annum compound interest with compounding occurring monthly. So how much does John need to pay per monthly so that he can repay the loan in 25 years? So you can see in this case, you're actually finding what is the payment for each month. So in this case, we only can use our TIN Spire Finance Solver to help us to solve this question. Because if you want to solve it by using recursive rule, then you need to try and error, then you generate different sequence, then you check it out. Then it will be very troublesome. Normally in this case, we only use our finance solver to help us to do it. Okay, so let's try to do that. So I'll end here. 25 year and then it's monthly, so 25 multiply 12, right? So you can just leave it like this, then you should always press this in your calculator as well. So the interest rate in this case is 8%. Alright, so I'm borrowing the present value, the money is with me, so that's why it's positive 450,000. So remember I put in 30,000 for deposit, so this is the amount of money that I borrow. Then after that, PMT is what we want to find, right? So repay the loan, so that's why the future value will be 0. PPY and CPY, the interest rate and also the money repayment is done monthly, so that's why 12 times per year. Okay, so by having all this information, then let's try to use our calculator to put in all the value here. Oh, sorry for that. Alright, so calculator. Okay, so n is 25 multiply 12. Okay, so you can just put like multiply 12 lah. So I 8%, PV 450000. After that, PMT is what we want to find, so just leave it. FV is 0, then PPY, CPY are 12. So just tap, then come back to the PMT, then just press enter. So you can see that for every month, this is the amount of money that you need to pay. So in this case, let's try to write down our answer first. So the PMT, alright, will be equal to, so again, in this case, we try to round up rather than round down, because if you only put 17, then it's not enough to clear your debt. So that's why it will be 18. So 3, 4, you can try to write this down first. 3413.17, try to put the full value, 298, right? Okay, then 27 lah. Okay, so which means in this case, roughly John needs to pay okay 3413.18 per month. Alright, so that's the idea. But in this case, there would no need to, very struggling with this part. So normally for the end part, then for sure, like just now the question there. So if you have like 56.0 something, they'll need to round up for 57. But in this case, I don't think 1718 made much difference lah. Alright, so that's the idea. Okay, B, how much interest in total does John pay over this year? So when we want to find the total interest, we try to find out how much total repayment that we do throughout the year, then minus off the total loan that we actually borrow. So which means in this case, 3413.18 multiply 12 times per year, then 25 years, then minus off the total money that I actually borrow, which is 450,000. Okay, so from here, then I'll be able to get, let's try to use the calculator to help us to do this. Okay, so we can get 1029233954. So yeah, again, this is like what I say, the sad reality about owning a house. So you can see that for you to borrow like 450,000, actually this is the amount of money that you pay for it. So you realize that the total interest, right, is even higher than the real amount of money of your house. And this is not only in the question, it's like what happened in real life situation as well. Okay, so this is the total amount of interest that actually John pay over the year. So if you are using 1/7, I'm writing these two down lah. If you are using 1/7, I believe that you might be able to get like one here. Then your answer here will become 5. The only difference is at the end here lah. So I believe that you get 17395 1. Alright, so that's the part. And now move on to question 10. Alright, so similar, this is about a house as well. So Jane wishes to purchase a house. So she has 35,000 saved to put as deposit on the house. So this is the deposit that she want to put in. So she thinks that she can afford to pay 2,000 per month towards the cost of a loan. So she plans to get a loan for a term for 25 years, making regular monthly payment. So the interest rate charged by the bank is 7.6% per annum compounded monthly as well. So CPY, PPY both 12. So what value of house can Jane afford? So which means that by using all this information, you should be able to calculate what is the loan that Jane can actually borrow. So the same thing here, what we can try to do is we try to find out what's the present value, what's the value that Jane actually borrow first. So we are not going to use this 35,000. So because that's the deposit, right? After we find out the loan, then after we add up, so after we find out the loan, then we try to add it up to the deposit, then I'll be able to find out what is the total value of house that she can afford. All right. So in this case, the end here. So she plans to get a loan for a term for 25 years, making regular monthly payment. Alright, so it's similar like what we have. So that's why 300 here. So I here interest rate is 7.6%. Okay, then after that, PV is what we want to get because we want to see how much she can borrow, right? Then after that, PMT, she can make regular monthly payment for 200, sorry, where is it? Yeah, she can afford to pay $2,000. So she give this money to the bank, so negative $2,000. Okay, then move on the next part. We have FV. So at the end of for the 25th year, she will be able to clear off all the loan, right? So FV 0, CPY, PPY here is 12 times per year. Okay, so let's try to key in all this value in our calculator also. Okay, so we have our N here is 300, so 7.6 interest rate. PV is what we want to find. PMT negative 2000, FV 0, then after that 12. Okay, so just go back, then after that PV. So you'll be able to get your answer in positive because that's the value that you want to borrow, right? Okay, so same thing, let's try to copy this answer. So we have our PV equal to positive 268,273.4425. Okay, So when you talk about this, then which means that the payment here, so Jane can borrow a loan, of 268,273.44. Alright, so that's the amount of money that she can borrow. So meaning that from there, then I'll be able to find out what's the total value of house that she can afford. So remember, the total value here will be equal to the loan value and then the deposit that she can put in before she borrow the loan. So just now we say 35,000, right? So try to add it up. So which means that in total, she can actually afford a value of house that is 303,273.44. Okay, so that's the idea here. So I hope that you can get the idea. So which means that from all the information, how much she can afford, she can actually afford a loan for this amount of money. Then after that, plus the deposit that she can put in for now, then that's the money that she can afford for a house. Alright, so that's the end for the example here. So I hope that I can spend some time to understand about it, then also spend some time to do the homework, then after that to try out the question. So if let's say you got any question, feel free to let me know. Alright, so that's the end for this lesson. Thank you.